nanti mungkin Pak Stefan juga akan menyampaikan masalah ini. Kemudian risetnya juga terkait dengan memperbaiki praktek dari metode pemodelan simulasi, baik agent based simulation, discrete event simulation, hybrid simulation, dan symbiotic simulation. Kemudian berbagai topik yang terkait dengan aplikasi dari simulasi pada bidang manajemen operasi seperti manajemen risiko bencana dan manajemen rumah sakit, dan juga supply chain management. Supply chain management termasuk di pertanian, dan beliau memiliki beberapa publikasi yang terkait dengan rantai pasok pertanian. Kemudian saat ini banyak mengerjakan proyek riset, dua diantaranya adalah Relief APS, yaitu Designing a Resilient Relief Supply Network for Natural Disaster in West Java, Indonesia, using optimization via simulation. Beliau menjadi principal investigatornya dan mendapatkan dana dari Engineering, Science and Research Council. Kemudian yang kedua, CRESOAR, Improving Community Resilience and Sustainability through Operational Research Capacity Building in Southeast Asia. Dan kebetulan kedua riset tadi bekerja sama dengan tim kami dari Universitas Padjadkaran. Oke Pak Stefan, waktunya 90 menit cukup Pak? Oke, cukup. Kemudian Pak Stefan akan menyampaikan kuliahnya dalam bahasa Inggris karena beliau katanya sudah lama Pak. Bahasa Indonesia bakunya udah ini apa ya? Jadi sepertinya lebih baik menggunakan dalam bahasa Inggris, dan ini merupakan satu kehormatan bagi kita. Untuk itu, silakan Pak Stefan.
Terima kasih Pak Tommy atas pengantarnya. Saya rasa saya juga cukup bahagia bisa share pengetahuan saya ke rekan-rekan yang lain. Semoga bisa. They basically sell horse meat, but they say they are selling beef. So people in the UK, especially in this Western world, they love horse as a pet, as a companion. So they don't want to eat horse. So that's why the meat is cheap. So that created a lot of scandals. So then, some people went to jail for that. And in the Eastern context, we can link this one to, say, for example, halal food, for example. We can also link this one to organic food, for example. So we can trace, so we know exactly where this comes from. We can also link it to, let's say, fair trade, so we know that by using, consuming the product, the agriculture product, we are helping the small farmers, the poor farmers somewhere in the world. So that is the concept of fair trade. So traceability is important because then that will allow us to do those good things. Yeah. Another thing that, again, when Pak Tommy and I visited a farm in Lembang, for example, and then it's really nice to see, maybe you can see here, there is a sensor located inside the greenhouse, and then from the sensor, then we can tell when the plants, in this case the vegetables, need water, needs some nutrients, so when to do things. So that means that with this kind of technology, it means we can use resources more efficiently. We can use water resources more efficiently. We can use this one is organic, so for example, we can also use minerals more efficiently, and so on and so forth. Yeah. So efficient use of resources is getting more and more important, as we know. Later on I will touch on this one, because the resources has become more and more scarce, especially for agriculture. Another thing is that the food supply chains can be quite inefficient, can be quite long. It's partly because of the globalizations. Say, for example, now in the UK, we can always get mango to go to waste. They redistribute it to people who really need food, who are hungry. So of course, they rely on volunteers. Yeah. These volunteers, they will prepare food and then distribute it to a lot of families or households. So in this case, from the website, say they distribute something around 24,000 tons of food, yeah. And they provide meals for equivalent of 57 million people. So this is the it's the social side of the food supply chains, where we are all human. I think we should not be celebrating or be happy when we see other people are hungry and cannot afford food. So try to balance. So because it's quite ironic, because at the same time we know that we are able to feed everyone on earth. But at the same time, we can see there are obesity in one part of the world, and then uh, hunger in the other part of the world. So we need to balance that. Okay, so it's just to give you some kind of introductions that will shape my lecture today. So I guess now the starting point is that after listening to those or to seeing those kind of examples, I'm sure there are a lot of other examples. I just picked 4 of them. The main challenge here for agriculture or agribusiness is that agriculture is the interface between the human system, us, and the natural system. So if you don't manage agriculture well or effectively, we can exploit the natural system, and that will not be good for the human system, because human system in, depends so much on natural system. Without natural system, human system will, well, disappear. Yeah, because our food, our livelihood comes from the natural system. So it means it is very important for agriculture to be sustainable. So we cannot simply focus on short-term profit or short-term benefits. We really, in the agriculture, we cannot afford that, because in the long run, we really, in the long run, we need natural system that is really sustainable. So we cannot exploit them um, for the sake of short-term benefits. So as I said, agriculture is the interface of human system and natural system. So that's why we have to manage it carefully. So that creates a number of challenges because, as you know, irrigated agriculture accounts for more than 70% of freshwater usage in the world. So that is significant. And at the same time, freshwater resources per person have declined by more than 20% in the last 20 years. It's partly because the growth of human population. So now, because there are more and more people, and at the same time, we don't increase the amount of freshwater resources. So as a result, the freshwater resource per capita have declined. Yeah. It means that while at the same time we know irrigated agriculture consumes most of the fresh water in the world, at the same time, the human populations, the growth in human populations, put a pressure on the freshwater usage. So the competition for freshwater usage will get tighter, will get more fierce. It's a large contributor to carbon and methane emissions. So, there is a need. Again, remember that we when we manage agriculture, we really need to think long term. So try to see the effect of. We cannot simply focus on short term benefit, because if you use short term benefits as a measure here, all we care is profit, for example, and we don't care about the carbon and methane emission for farming, then we will be in trouble in the long run, because that will create climate change, and then climate change will affect the food production. So in the long run, short-term benefit will not be good. So we really need to balance between short-term benefit and the sustainability of the farming. Now, another pressure that I have already mentioned earlier, partly because of the human populations, the increase in human population, is that because we expect that there will be more and more people in the world. It means that agricultural productions will need to expand by approximately 70% by 2050 in order to feed all people in the world. Now, imagine we have to do this one in the context of limited resources, save the fresh water that I mentioned earlier. And at the same time, we know that there is an increasingly degraded environment because we exploit the environment. The soil, the quality of soils have degraded. So the quality of biodiversity in the world have suffered, and so on and so forth. So while we have to expand the productivity, the production of agriculture, at the same time we are challenged by more and more limited resources. And climate change doesn't help, because climate change means that the rainfall pattern is disrupted. I think you can, whenever you talk to farmers, they probably aware of this one. They probably suffer from this one, and there is also an increase because of that. There is an increased drought frequency. Those are not good for farming. Another point, just to give you more more perspective of the challenges, is that we rely only to a number of few species for our food, which means that we the diversification in our food consumption is quite it's not good. So it's quite risky. So maybe we need to change our behavior, need to diversify what we eat, what we consume. Yeah. So that is another challenge. And in some countries, food is expensive, is relatively unaffordable because of the inefficiency in the food supply chains. So this is a highlight the importance of efficient food supply chain, because efficient food supply chain means you can minimize the cost so that food will become more affordable to more people. Now, the United Nations estimated that at the moment about 690 million people are hungry. So this is really they suffer for the most extreme hunger. So 9% of the world populations. But if we count those who have to skip meals, so what we call mediumly affected by hunger, is 26% of the world population. That is 1 in 4 people in the world. So these are quite a set figure for our world, for the society. How come there are 1 in 4 people in the world have to skip meals in 2019? And this is 2019, meaning that it wasn't affected by COVID-19, right? This is the era before COVID-19. Now with COVID-19, so we are pretty sure the number will be much worse than this. So that's why there is another challenge, which is how can we make food supply chains work for all people, including vulnerable people, for small-scale producers to billions of consumers, low-income consumers. Yeah, and then one of the things that we need to do, not only for the efficiency in the food supply chains, but also we need to reduce food losses. We need to really to minimize food losses. Okay. So those will create the scenes for my next point, which is what can we do about it? So one of the tools that we can use is technologies. I highlight, repeat again, is one of the tools. It's not the only one, because you also need policies. You also need behavioral change and other things to solve this problem. So technology is only one of them. So today I'm going to explain about the technology side of it, which is related to Industry 4.0. So before I explain, so what is Industry 4.0? Maybe we go back to history first. If we go back to the history, we have experienced 3 industrial revolutions. the first one I think we learned from when we learned history. I don't know about you, but when I was in, I think, probably SMP, probably, yeah, or SMA, I don't remember now. We learned about because of the steam engines that drives what we know as the first industrial revolution in the UK, in England at that time. So this and then after that we have what we call the second industrial revolutions. This is because of the mass productions, the assembly line, and the last one that we experienced was the third industrial revolution with the computerized production line. So then we have what we call flexible manufacturing system, and now we are, I think, at the beginning of the what we call industrial 4.0 or the fourth industrial revolutions. Let's look at the history bit before we move on to what happened now, just to give us the development, because this is maybe it's not really revolution, it's more like evolution, because there is yeah, there is a red line, there is a thing that connect all of these revolutions. So as I mentioned earlier, Industry 1.0 started with the invention of steam and water powered engines. So that will change because of the new technology at that time was new. That changed productions from hand productions to machine productions. The main products, the main goods at that time was textiles, iron, and coal. Of course, when new technology comes in, there are people who will benefit from it, and there are people who are the losers in this case, because you change from hand production to machine productions. A lot of people livelihood was were affected by this new invention. So that's why what we learn from here is that we need to get ready. Whenever there is new invention coming, we need to get ourselves ready for the future. Yeah. This is just a part of the history that at the time was because another example of how technology can change the world. At the time, Eli they invented machines to produce cotton more efficiently. Because of that inventions, this is in the U.S., in America. Because of that, people don't need more slaves to produce. They need fewer slaves to produce gin. And what is the result of that? The civil war in the U.S. Because then people, they so, in the North Americans, they want to get rid of the slavery, while the southern part of America, because they still dependent on slavery, they don't want to get rid of the slavery. So that as a result there was a civil war. So again, so one technological inventions, the impact of one inventions can cause a lot of social changes. And the demand, if you look at that at the time, for industrial product is more on the volume. Everything's driven by volume. Can we produce more textiles in shorten more textiles more efficiently? Yes, we do it via machines, not hand production anymore. So the dimension of demand is more on the volume. How can we produce more and more items using machines? Okay. One of the notable scientific work at that time was by Adam Smith. Maybe some of us learn about Adam Smith's theory about the invisible hand, which is the price. Price is the one that controls supply and demand. Yeah. So just to give you a brief of history at the time. And then this is followed by Industry 2.0, which is with the invention of electricity and electronic and mechanical devices. This is where cars were produced at the time. So the question at the time is not only how to increase product volume not only increase the product volume, but also with a low cost. So the answer to that is mass productions. So some key people at that time was Henry Ford. Again, it invented the mass production of assembly line to produce the cars, Ford cars. Yeah. And the dimension of demand now is not just volume, but also variety. So now people also want to have a bit more variety, not just one product, but multiple products. But at the same time, it's quite ironic because one of the very famous Henry Ford's quotes was, you can have any cars you like, any colors of cars that you like. Uh, yeah, apart, sorry, you can have any colors of the car that you like, uh, but you will basically they only produce black car at that time. So it's a bit ironic, but the other example like Sloan, Alfred Sloan, and Taichi Ono, they really focus on the variety of the products as well. So that is the industry 2.0. It's basically dominated by the cars manufacturing system. And this is the importance of industry 2.0 is that is what we probably uh, perceive as the birth of analytics, the principle of scientific management. That's where um, the, how we apply operational research and management sciences in commercial sector, in productions in this case. So this is one of the early works on operational research. Yeah. So that is one of the key points in history. Now, Industry 3.0, this is where I think Pak Tommy and I was born in this era, where at the time the invention of digital electronics, information technology, and modular design that drives, again, the innovations in productions. So if you look at here, Industry 2.1.0, 2.0, 3.0, they are all driven by new technology, new inventions. Yeah. So in Industry 3.0, the new technology was digital electronic, information technology, and modular design in the production line. This is what we experience, that products now have shorter life cycle. I think probably we probably may have heard this one from our parents when they say why the new products they don't have a long life cycle like the old products in their era, because that is the reality. Products now have shorter life cycle because the new products keeps coming in. Yeah. And the dimension of demand now is changed. It's not only volume and variety, but also delivery time. So yeah. So the dimension of demand now changed because now there is a shorter delivery time that is becoming more and more important. So people and the customers are not simply happy by having a lot of products that are cheap, volume, variety of product with variety, but they also insisted that the delivery time has to be very fast as well. So that puts more and more pressure to the manufacturing, to the producers. And the main technology at the time, sorry, the production at the time, then this one is achieved by several clever manufacturing designs using what we call flexible manufacturing system with the invention of a lot of computerized machines, yeah, like CNC, and also software like computer-aided design, computer-aided manufacturing, and so on and so forth. Now from Industry 3.0, which we have experienced, now we are looking at what is happening now. Because the good thing about learning from history is that we can prepare ourselves for the future. And because the future, whether we like it or not, is coming. Yeah. Whether you want to be the winner in the future or you will be part of the losers. So it all depends on our decisions now at the present. So let's look at the evolutions now. In Industry 1.0, yeah, in Industry 1.0, if you look at the demand, the demand pressure, customers, they focus on volume, cheaper price, yeah. And then after that, customer kind of, they change not only volume, but they also like variety. Then in industrial, in the third industrial revolutions, customers now not just cheaper product, more variety, but they also want it now. So they want the product now, basically. So the delivery time has to be short, very fast. Now, from these three historical facts, we try to forecast or predict what would happen in the future. Would it be what we call mass customizations? It means that people will like a personalized product, and that can be produced cheaper and faster. Yeah. So mass customizations. So one of the things that we can think of is, for example, the 3D printers technology. Probably will grab that, and anything that is can mass produce but is quite customized to our needs. Yeah. So that is the pressure from the demand. Um, if you look at the production technology or the production system, we start with the engine productions. Yeah, so we change from hand production system to engine productions, and then after that we move to what we call production line or mass productions, and then after that we change to flexible production lines. So with the production flexible manufacturing system. Now what is going to happen in the future? In fact, we can see it now that they are moving towards more and more smart factory. Yeah. So we can roughly see what is going on, what is happening at the moment. So this is probably the future now, the smart production system. Now, if you look at the technology evolutions, we started with steam engines in the first industrial revolutions, and then move on to the electricity in the second one, and then the electronics devices and ICT, the computer technology. And then what is the new technology at the moment? At the moment, we have seen what we call cyber physical system or CPS. We have seen Internet of Things, IoT. We've seen analytics. We've seen blockchains, and so on and so forth. How can those technology? What does those technology mean to the productions in the future? So that is something that we need to understand. How does this technology, how does this customer demands affect agribusiness? Yeah, not just manufacturing, but also how does it affect agribusiness? How does it affect agriculture? So to summarize, basically, there are a number of technology that enables what Industry 4.0 looks like. So at the moment, we are still debating whether the fourth industrial revolution has arrived. I think most people will think that we are still at the beginning of it, because one of the things that enable industrial revolution, as we learn from history, is new technology. Is there any new technology that can disrupt the current production system? So the new technologies that we think may disrupt what is happening now is Internet of Things and cyber physical system. These are the two main ones. And then at the same time, there are other supporting technology like cloud computing, virtual and augmented reality, robotics and 3D printers, and big data analytics, simulation, and AI. So these are what we believe might revolutionize the way we produce items. So let's look at them one by one, because the two main ones is Internet of Things and cyber physical system. So I will spend a bit on that, because it is important for you as agribusiness experts to understand the current technology. Because once you understand the current technology, then you can exploit what can we do with it. How can I innovate my service, my products with the new technology? So Internet of Things basically is a global network infrastructure where all devices are connected. So they rely on sensors, communications, networking, and information processing technology. So you can think Internet of Things as the connected devices, yeah, in a simple term. Yeah. But underneath these simple terms, there are quite a lot of smaller technologies that allow IoT to work. Something as simple as RFID so Internet of Things, some of them rely so much on RFID, some of them rely so much on smartphones, yeah. They also rely on a lot of services, including social network, or even a lower level network like RP6, for example, or Wi-Fi, and so on and so forth. So, but I'm not going to discuss that in detail, but you can think of this one as the connected devices. So, what can we do when devices are connected? So, use your imaginations. What happens if you know, for example, your apps can tell what is inside everybody's refrigerator, for example. What can you tell if you know about the history of the purchasing from certain customers? So you need to think about how can we innovate, how can we benefit from those kind of information, that those kind of processing technologies. So this is also allows us, Internet of Things allows us for real-time communication between objects, between devices. Yeah. So in this case, then, for example, now I'm working with my friends, working on a new research grant, for example, looking at sensors. So my friend is they are developing sensor to be put on 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 the farms, yeah, to monitor the food supply for animals, for cattle. And then how can we monitor with the real-time monitoring of the food supply, the level of food supply at farms level, and how can we optimize the delivery so then the farmers will get the food when it's needed. So we make sure that the food for cattle will always be available at the cheapest possible price. So that is again, knowing that we have this kind of equipment, what can we do to improve our business? What can we how we innovate? How can do innovation, knowing that this is now possible? Now, yeah. So the communications, of course, that will be expanded by the use of cloud computing technology, because with cloud computing technologies, we don't have to invest in computing power, because we can always run more and more computing resources as we need. If we don't like it, then we just simply don't pay for, uh, just buy enough. While in the past, once we buy a computer technology, computer hardware, then that computer hardware will stuck with us. But here we can always use compute power in the cloud, which basically we just renting the computing power. So, and the current technology also allows communication between a larger number of autonomous machines. So there is a machine-to-machine communications. So in the future, we know that this will affect, say, for example, traffic or cars. But how is it going to affect agriculture or agribusiness? What happens if the different machines, they connect to each other, they talk to each other. So you can think of any machines, in the smart homes, yeah, smart houses, and then what happens if they communicate with each other? So yeah, again, it's the sky is the limit. You need to think about what can we do, how can we innovate, how can we gain something from this. Yeah. So I will share my slides with you after the lecture, so you can also see this YouTube video to see how Internet of Things work in practice. Yeah. So then you have a better idea about what it is. Now, the second technology that is quite important in that we think can be quite important for Industry 4.0 to happen is Cyber Physical System or CPS. So basically this one is a system, industrial automation system, or simply just a system, because if we are talking about agriculture, it's the same. It's a system that integrate what we call the cyber world or the digital twins. This is the virtual world, and the physical world, which is the system, the real world system that we want to manage. So this one, at the moment, mostly are manufacturing system. But in our context, in my lecture here, this one can be replaced by agriculture system. This is, we can change it with agribusiness, with agri-food supply chains. Yep. This part can also be replaced by hospital or healthcare, hospital management system. Right? We want to manage hospital using a virtual hospital. So in this case, the idea is that if we have the simulated or the virtual world, then we can play around with virtual world, and then if we know what is the best course of actions in the short term, in the near future, then we apply that decisions to control the physical system. Of course, when we change how the physical system works, that will give you a new performance, new behavior. Now, the new performance will be fed back, will be sent back to the virtual world so that the virtual world can learn, oh, the decision that we made earlier was correct or was incorrect. So in the future, we can make better decisions by learning from, by learning from the feedback from the physical system. So that will make this symbiotic system smarter and smarter in the future. Yeah. So I hope that can give you an idea about how cyber-physical system work, about the symbiosis between the virtual world and the physical world. So this, of course, will be enabled by sensors, because if you look at here, the virtual world will get information from the physical world through sensors. And also depends on what we call actuators. Actuator is the means in which the virtual world can control the physical world. So that can be a robot, that can be some kind of machines, yeah. So, or even we can also use human as a mediator between to control the physical system, yeah. For example, in the case of hospital, then the actuators can be human. And to make to decide what is the best course of actions in the near future, that is where we need analytics, the business analytics model. So that is the role of analytics. So now I hope you can see that why these are important, these are necessary for a cyber physical system to work. And CPS has been around in the industry for quite some time now. Yeah. So as I have already mentioned, sensor, actuators, and human-machine interactions, basically that allows the interaction between the virtual world and the physical world. And the analytics model is the most is really important because that is the one that we use to make decisions so that we can control the physical system effectively. So this is simply the explanation of the slide before. Okay. And in this case, with this cyber physical system, decision making can be transferred from the centralized system to a decentralized system. So in this case, that maybe machines can make their own decisions now. Yeah. So we can. So what happens if these machines, they can make their own decisions and then they can work in harmony to deliver what to deliver a very good, efficient physical system. I don't know whether you have seen how, say, for example, modern warehouse works. So maybe if you Google how Amazon warehouse distribution center works, you can see that they have a lot of unmanned vehicles moving items around, for example. So that is an example of, and where every unmanned vehicle, they make autonomous decisions. Yeah. So, and it's really amazing if you look at the video that they don't clash with each other. They can find the best route to uh, to, to, to to reach their destinations. So if you have time, just Google how um, these, let's say, modern warehouse works. Yeah. Okay, so I have already mentioned about data analytics earlier. The role of analytics is quite important because this is the brain of the system. This is the brain who will make decisions. What is the best course of actions in the near future? Yeah. And remember that Internet of Things, or you can think of this one as a sensors. Internet of Things relies on sensors, and sensors produce a lot of data. So it means that we need a place to store the data. So this is, and the solution is cloud. So it is possible now to store, gigantic amount of data in the cloud. Yeah, I'm pretty sure many of you have already used it. You store your video, photos on your phone. Actually, that will be linked to a cloud system. Yeah, so it is possible. And the challenge for analytics here is that how can we design analytics techniques that is efficient and can process the massive amount of data generated by the Internet of Things. Yeah. And this data, the volume can be quite high because it produces a lot of data, and the data is produced at high speed, at high velocity. Say, for example, if you look at the movement of traffic data, that can change from minutes to minutes. If you look at the financial data, it can change from seconds to seconds, for example. So um, at the moment in the world, massive amount of data are produced at the fast speed. And then the variety of data has increased significantly. Now we are not just collecting textual data, numbers, but we are also collecting videos, pictures, we are collecting sounds, and so on and so forth. Yeah, and because of the sensors, so that is what we call variety. Now, the fourth dimensions of this big data, the veracity, means that the data that we are collecting depends so much on sensors quality and reliability. So it means that data comes in various quality. So data can be inaccurate, but the level of inaccuracy varies. Yeah. So then the challenge is how can we make decisions based on data, and we know that some of the data are not reliable. So that requires a challenge for analytics. Okay. Okay. Now, if you're talking about the analytics, there are three different types of analytics because, as I mentioned earlier, analytics is important because this is the brain in the system. So we have the virtual world, we have the physical world, and then the brain that make decisions is the based on analytics. Now, analytics can be divided into three types. One is what we call descriptive analytics. That is analytics analytics techniques that are used to answer questions, what happened? So we want to understand what happened from the data. Once we know what happened, then we want to predict what are the trends, what might happen in the future. So that is what we call predictive analytics. Now, once we know what to predict, once we know what might happen in the future, then can we optimize what we want to do? So can we get prescriptions of what to do so that the result in the future is what we want, is the best, based on our certain criteria. So that is what we call prescriptive analytics. Yeah. So those are the three types of analytics. Now, I'm not going to spend too much time on virtual reality and augmented reality, but this is part of the technology enablers of Industry 4.0. Yeah. So you can Google smart glasses, and they are they are used very, they have a very good potentials in manufacturing system, and maybe in the agriculture system as well at some point. So you can imagine if you wear smart glasses and then you look at, say, a cow, and then you straight away know the details about that cow, for example. Oh, what is the age of the cow? When was the last time the cow was what is it called? Got the food, and then the medications for the cow, and so on and so forth. So that is the application of smart glasses, and that can one of the key enablers of the Industry 4.0. Yeah. But I'm going to explain a bit more. So I provide a link to a YouTube channel so that you can understand better about how this technology works in practice. And the actuators, the one that I mentioned earlier about actuators, is important because that is the one that can control the physical system. Now, the actuators can be in the form of 3D printers. So 3D printers, they can produce something. So it means that in a way, we control that productions. And can be robots, because then robots can do something that we want from the instruction from the virtual world. So that is called actuators. Actuators is the one that do something in the physical world, yeah, by commands from the virtual world. So that is the importance of the actuators. Okay. So again, I give you some links so that you can understand and see how these actuators are used in practice. Okay, so I guess that is the end of my lecture on Industry 4.0 technology. So now let's reflect back what I have explained to you. I started with the challenges in agriculture and agribusiness. And then I explained about Industry 4.0 technologies. Yeah. So what I'm going to explain next is try to link the two. How can we use these technologies to answer, to respond to some of the challenges in the agribusiness? Yeah. Okay. So one of the key technology that I'm going to explain, sorry, this is the technology that I'm going to explain. Actually, I'm going to explain one technology is what I call symbiotic simulation system. So think about it as like this. So let's say you have an airport. This is our real life system. This is our physical system that we want to manage, we want to control. And as you know, airport operations, they produce a lot of data, and those data are stored in what we call enterprise data storage system. So those data like arrivals of aircrafts at the gates, passengers time, you know, the passengers entering the aircraft, yeah, the loading time until finished, yeah, and boarding time. Sorry, the word just escaped my brain just now. Maybe I need a bit more coffee. Boarding time, yeah, and the next one is a lot of data there, right? Yeah, they generate a lot of data. And then from this historical data, and also they also produce, so those data that is stored in the enterprise data storage system will become historical data, yeah, past data. But at the same time, this airport operation also produces real-time data, what is happening now. So from the sensors, so we know what is happening now. Now from the historical data and real-time data, those will provide inputs to our virtual world, to our digital twin, or in our case, I call it SSS, yeah, symbiotic simulation system, or you can call it the digital twin. Yeah. So the digital twin receives inputs, two inputs. One is the historical data and the real-time data. They are the same type of data, it's just the difference is in the time it was produced. Yeah. So from that, of course, we kind of do some kind of forecasting to try to predict based on the past data, try to predict the future so that we can optimize, so that in the future, so we can get what we want in the future. So then once we know what is the best course of actions to achieve what we want in the future, then we make a decisions, control the physical system, control the airport here. Yeah. Now, of course, by changing the operation in the airport, then we will get the feedback, okay, because of that changes, now the data has changed. Now, by observing the change and our decisions, the system, the future world system can learn, oh, actually, my decision was not correct. So it means in the future, I will not make that decision anymore, or I will need to adjust my decisions. But if the decision was correct, then I know that in the future, I will make this kind of decision again. Yeah. So there is a learning system here. So that's why over time, the system, the symbiotic system here will become smarter and smarter. So I hope you get the idea how it works conceptually. Now, if you look at into the detail of the symbiotic simulation system itself, so we want to look at the detail of what is inside here. Yeah, what is inside here. So if you look at here, inside here, we have what the data acquisition components that get all the data, and that will serve as an input to the analytics and machine learning system here, and they will talk to the core of the symbiotic simulation system, which is the symbiotic simulation model. This is the one that will simulate the real system. And then there is an optimization module that can, that optimize what might happen in the future, so that we can get what we want in the futures. Yeah. And then the output of the optimization model is the one that will be fed into actuators or decision maker. So the actuator can be human if we want human to make the final decisions, or can be a machine if the decisions is automatic. Yeah. So that is how, if you look at the detail, how it works. To give you a bit more example, clearer idea of how it works in the system is something like this, right? So you have the virtual system that control the physical system, and this one is through the control system, or what we call actuators. So using actuators, we can control the physical system. Physical system will produce measurement system, which is what we call sensors. Through sensors, will produce feedback to the virtual system or the digital twins. Yeah. So in a way, that will, So in a way, you can imagine the virtual system and physical system runs concurrently, and they keep sending informations in between, from virtual system to physical system using actuators, from physical system to virtual system using sensors. Yeah. So you can imagine here, this is the historic data, and then we have the recent data, the real-time data, and now we are at this time, and then we run our simulations, yeah, and you comparing different scenarios, find the best scenario, and then apply that scenario, and then we move to the next time. We repeat the same thing again. What was recent data becomes old data. Now we have new recent data, and then we repeat the process once again. So that is what happening all the time. And every time, the system will learn from the past. So that's why it will become smarter and smarter. So the system can decide, or in certain conditions, scenario 1 is always the best. In certain other conditions, scenario 3 probably is the best, and so on and so forth. Over time, the system can learn. Now, if you apply that one now to agri-food supply chains, so typical agri-food supply chains will be, you have the input industries who produce a seed, produce pesticide, produce the food, food supply, and then they will supply farmers as the production, the center of productions. So farmers will produce the agricultural products, and that will be typically will be sent to a processor, and then from processor it will be sent to consumers or retailers. Now you can imagine that in every steps in the supply chains, they will produce a lot of data, and then we can see the potentials of different kind of technologies that we can use. Yeah. So for example, from the farmer side, they can use say e-agriculture services where they can make decisions about when is about the schedule, the planning schedule, the planting schedule. So when to plant certain seeds and how many of them, for example. This can be where the schedule for pesticide, giving the pesticide, for example. So that kind of services can be offered to farmers. Likewise, for processors, that will be something kind of optimization of the delivery of the collections of items from different farmers, so they can optimize this. Yeah, and then again at the consumers level, a lot of data has been collected by supermarkets about consumer behavior, about their purchasing behavior. That can be also used. That can also provide a lot of data for the virtual system here. And not only that, the virtual system can also help with the decision making. So the actuators, the one that I mentioned earlier, for example, by uh, changing consumer behavior, nudging, giving nudge to consumer behavior. Hey, why don't you buy these products? Yeah, instead of that product. So if the system can do something like that, and if the objective is try to make the food more secure, for example, we know that, for example, we can predict that the stock, the inventory of these food items in the future will be a bit low. So while the other food items is quite high, so we try to redistribute the demand, for example. So we can, there are a lot of ideas that we can think of about how to apply the technology that I mentioned earlier into an agri-food supply chains. Yeah. And in fact, some examples that I gave you in the beginning, very beginning, they have already done that. Yeah. So we probably need to keep innovating. What can we do next, and so on and so forth. Yeah, to make our life better. So this is so for the next few slides, I will just give you briefly about some of the technology that are available. But of course, these are just samples. There are so many other agricultural technologies at the moment. Yeah. So this is about sensors. So it means that you can see here the farm. They are the physical system that we want to control, but we can also do virtually overlay digital content on top of the farm, so that we can roughly know, oh, the red stuff here, they probably need more, let's say, more water than the green part, for example. Or maybe the green part is the one that is ready for, I don't know, something. So, so, so I hope you can see the idea here that we can, so the physical system that we want to control in this case is the farms, so the paddy field here, and then we have the virtual system that represent this field, and that from that we can optimize say for example the water usage, for example. So we can optimize the pesticides, for example. So we can do a lot of beautiful useful analytics to optimize the production system. Now, there are so many sensors, as I mentioned earlier, about locations, about the camera, and multispectral camera, and a lot of things that we can do, like measuring the soil conditions, the crops conditions, and so on and so forth. So, I think you probably know better than me about the agricultural sensors, but these sensors are the one that we will use in the IoT system, the Internet of Things system, that will feed data into the symbiotic simulation system. Because my main area of research is on the symbiotic simulation system itself, not in the sensors. But my system relies so much on data that is collected by sensors. Yeah, so that's why it is good for me to know more what kind of data that we can collect using sensors, but sensors is not my expertise. So as I said earlier, symbiotic simulation relies so much on the sensors, but also relies so much on the actuators. So once the symbiotic simulation system makes a decisions, then we need someone or something to operationalize the decisions. So this can be operationalized in agriculture using rate fertilizer, variable rate fertilizer. Can be used, can use the spraying machines, can use UAV or robots. We can use the vehicles, automatic vehicles, and so on and so forth. So those are the examples of actuators. And of course, the most important actuators are the farmers or the humans. Yeah, so they will make the decisions. Okay, so if we combine the technology, the symbiotic simulation technology, and here we combine it with the sensors and we combine it with the actuators, then this is what I envisage as the Agri-Food 4.0. So this is where you know, the Agri-Food production system is completely sorry, not it's completely is supported by advanced technology, advanced industry 4.0 technology. So we use sensors, we use analytics and symbiotic simulations, we use the actuators to control the production system so that we can address some of the challenges that I mentioned earlier. So it means that we use, say, for example, resources as efficiently as possible. So we don't use more water than what is needed. We don't use more pesticide than what we needed. So we can minimize the soil degradations, and we can produce, you know, so we try to minimize food waste at the farmers level, for example. So those are the things that we can do with Industry 4.0 technology applied into agri-food supply chains. So that is one of my key messages in this lecture. And yeah, there are many ways. This is maybe, if this one is an example in agriculture, this is probably example in herd. So for cattle, yeah. So again, the technology will allow us to track individual movement of cattle and in fact the behavior of the cattle, yeah, and can provide some early warning system. And yeah, this is again another examples to give you an idea about, you know, once we optimize the system, then we can give enough, you know, water, you know, different level of water, different level of pesticide at different part of the farms. So the colorful here are, of course, they are the virtual world laid on top of the physical world. So then the machine, the robot, can tell how much water or how much pesticide should be given in different area with different colors. Yeah. So finally, I think this is to give you an idea about different kind of use cases for smart farming. So in the future, so this one I've taken this one from McKinsey. So smart crop monitoring. So you can get this. So we also have drone farming in the future, near future. Yeah, we have the smart livestock monitoring system, the one that I mentioned earlier. We can also have the autonomous farming machinery, the one again, the photo earlier that I mentioned, and many other things. Yeah, so that will be become more and more widely used in the future agriculture system. So this is again just to re-emphasize that analytics can be used in any part of the food supply chains, in the input industry, in the farmers, productions, or in the processors, on the retailers. And I just give you one example from my earlier work, where the focus is on between farmers and retailers. Yeah. So in this case, that I assume there is one farmers or big corporation here, and then there are some retailers, retail centers, RC. Yeah, and this is the one big. You can think this one is one big processor or one big farmer or one big corporations. Yeah, and they supply a number of customers. So in this case, each customer will have their own stock, and we need to optimize the routing and the replenishment at each retailer in such a way that we will, oops, there is animations, completely forgot I put that. And then the objective is, in this case, is we want to minimize the total cost, the routing cost or transportation cost, the inventory cost, the stock out. Stock out means that when customer needs it, the retail center needs it, but we don't have enough stocks, then we will be penalized. Yeah, so stock out cost and waste cost, because we don't want to waste food. So remember, the system is about agriculture where food items are perishable. So if we store more items, perishable items at the retail center, and we are not able to sell it, then the food will be wasted. Now we want to minimize that wastage here, the wastage. Excuse me. Okay, so that is basically what my recent work is about. So we want to optimize this one. So this is an application of analytics. So then we can give decision makers kind of advice. So in this case, it means that the replenishment at each retail center has to be this. So we give them the optimum replenishment policy, and at the same time, we give also the optimum routing or transportation policies. Yeah, so that is the output of the model. If you are interested, you can also look at the paper that I will send you after this. And yeah, one more thing that I forgot to mention. In this case, we assume, just like in the real world, that the demand is stochastic. We do not know what the demand is, but we know there are some patterns on the demand, but it's completely stochastic. Okay. So in summary, I hope still remember, in the first few slides, I explained about the challenges in agribusiness. Yeah, remember that with some photos. And then after that, I explained about the Industry 4.0 technologies. And after that, I combined both. So then to explain about how we use Industry 4.0 technologies in agri-food supply chains to make agri-food supply chain better. And I put a lot of emphasis on the role of business analytics, including the symbiotic simulation system. So basically, those are some of the points that I have already explained in this lecture. So I will give you, these are the bibliographies, some of the resources. I already sent some of the papers to the organizer, so then they can distribute my slides and the papers to you. So I think with that, I thank you for listening to my lecture, and I give the time back to the moderator. Let me stop sharing now.
Pak Stefan. Yeah. Okay, thank you, Pak Stefan. It's very interesting presentation. Okay, we have 15 minutes to Q&A session. If you, the participants, has a question, please raise your hand or directly question to Pak Stefan. Okay. Hari Wiono Putra, please, if you have any question, you can open your microphone.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good evening, Mr. Onggo. First, I'm Hari, first year students at Agribisnis. My student numbers is 013. Okay, speaking about how to improve supply chains management about agriculture business. So Agribisnis startup is one of the answer to fix it. Okay, also we know that the demand of agricultural product always grow over the time. So, but we know that in Indonesia especially, the process of moving traditional market to e-commerce are so jammed. Okay, my question is to speed up the adaptation of agricultural e-commerce in Indonesian, which do you prefer? it is good to make a lot of agribusiness startup brands, or it is better to make only one brand to monopolize the agribusiness startup. Firstly, in order to make people adaptations, in order to speed up adaptation of people from knowing agricultural business in Indonesia. Okay, thank you, Mr. Rongo. That's my question.
Um, it's a difficult question without knowing the context or the culture or the local culture. But if if I'm looking at it from the perspective of capitalist, then of course competition is the answer. But if I'm looking at it from if there are some, because there are some, you can probably in some cases probably the second options is better. So there is no, for me to be honest, there is no right and wrong answer. It is important for, I think the key thing that I would do is to collect more data to understand why, what is the factors that prevent or encourage the adoptions of e-commerce among the among the populations, yeah, the farmers, for example, or the market players. Once I know a bit more detail about what the important factors, then I can make a better decisions. What is the best strategy here? Yeah, I don't know. So, for example, if the one of the factors that they maybe because they are they are more risk averse people in the market, then is there anything that policies can help to in a way to share the risk with, of course, the promise of some benefits when the business is successful. So there are a lot of business models that we can use to solve that problem. But the key here is that understand better why you think that people in the market, they don't want to move from traditional market into e-commerce or even to say short food supply chains. So I think Agri can help because Agri's research is trying to understand those factors, right, Agri?
Okay, thank you, Mr. Rongo. It's all about we check our data analytics of the customer wants to if the market is traditional or the market is e-commerce. Okay, thank you, Mr. Rongo.
Okay. Thank you, Hari. Agi will add answer.
Bapak udah.
Okay, the next question from Atar. Please, Atar.
Hello.
Yeah.
Okay. First of all, good day to you, Mr. Onggo. My name is Athar Rizan Kautsar. I'm from Agriculture Faculty, majoring in Agribusiness, and my student number is 074. In your presentation, you said that there are machine-to-machine communication, right? So there are strength and durability, and machines are wait. There are strength, durability, and other qualities that makes machines are superior to us. What I mean is that that way we can increase effectiveness production-wise using machines. Okay, and now the question is, what do you think is the quality of humans that differentiates us with machines and AI?
At the moment, it's an interesting question. At the moment, one thing that human has that machine doesn't have is empathy, emotion. But at the same time, I know there are research about how to implement emotions into machines in the AI community. I guess machines are very good at the moment, yeah. I'm not talking about the future yet. At the moment, machines definitely better than us for repetitive tasks. They are better at memorizing facts, memorizing numbers than us. But we are, in a way, we are better at kind of any work that requires matching between certain things. Yeah. So quick glance of certain two that is seemingly unrelated factors. Yeah. While machines, they rely on what we feed into them. So if they want to do pattern matchings, then we have to feed them with certain things. But human force probably is a bit more agile. But again, the gap is closing because as the AI researchers, they know once they know about how human brain works, how human works, then they try to replicate it in a machine. So it's the gap is getting narrower and narrower. So I think it's the question is not about for me, the main question is not about man versus machines. Is that, okay, if we release some of our tasks to machines, it means that human, we can focus more on something else. So we can focus more on things like more strategic matters, something that requires a lot of, something that's more irregular, something that can respond very something that because the main human quality is our learning system is quite human can learn can do a lot of extrapolations based on past experience. It's not always good because sometimes it's create bias. Yeah, it's not always good, but that is one of the qualities that we have. Yeah. So maybe it's because of the evolutions about fight and flight nature of human in the past. So if we don't, if we know that we are not going to win, then we have to fight. Yeah, we have to run. So so that creates a lot of bias in our brain. For example, if you look at someone straight away, you try to think about in the past. When I meet someone like this, usually it doesn't end very well, and then your nature says, okay, let's run. When you do business, sometimes we use intuitions, right? So intuitions, again, that is bias created from the past. So that is something that what human does and machine doesn't do at the moment. Yeah. So I guess, as I said, it's not about man versus machines. The most important here is that how machine can complement us in making better decisions. So that's why in my my example about symbiotic simulations, typically the actuators include human, because human at the end have to make decisions. And one more thing, okay, now you remind me of something. We are living in a league with other people. So at the end, we need someone, human, to be responsible so that people will not blame computers or machines. Say, for example, if you have a self-park car, a car that can self-park, which is now available on the market, yeah. So what happens if the car hits another car? Who is at fault? Can you blame? Who is at fault? Who is going to pay for the damages? So there is a legal system that we have to solve. So in this case, is it the manufacturer, or is it the insurance company, or is it the driver? Because the driver can override the system. So that is, regardless of what machine can do or what human can do, the legal system of infrastructure has to be clear, and that has to be designed by human. So we are still living in a human world, so we need human to be responsible for the decisions at the end of the day. Yeah, so okay, that's probably my my answer. Tough questions.
All right. Thank you very much for your explanation.
Okay, thank you, Pak Stepan. In Zoom group chat, Professor Tufawana asked about is there any example about the application of Industrial 4.0 in agriculture cooperative, maybe in UK or
Ini si Tommy, nih Pak Onggonya nih.
Yeah, maybe in the UK and the US,
ini,
but
ini,
again,
ini
it's
dia,
still
Professor.
not widespread. It's still because the technology itself is still expensive. That's the main issue.
Bahasa Inggris semua.
It's still quite expensive. So probably it will be getting as we know, all technology will get cheaper over time. So at the moment, the main issue is it's still expensive. Yeah.
Okay.
And also the main issue, another issue is that it's about the if you look at the agriculture 4.0, is the integration between technology. Some technology are more ready than other technology. So for example, now in the UK, we have robots that are able to pick, say, strawberries from the farm automatically. But it's still probably not linked with the other systems, say like the brain, the data analytics part, maybe it's not integrated with the sensors and so on and so forth. Yeah, so it can pick strawberry, but whether the technology can, but it hasn't been integrated with the sensors that can identify this strawberry is ready to be picked. Yeah, it's ripe enough to be picked. And also it's still expensive.
Okay, thank you, Pak. Okay, the next question from Ade Baharudin, please. Ade.
Okay, good evening everyone. My name is Ade Baharudin from Agribisnis 20. I want to ask about, well, from today in Indonesia, there is many farmers that they are managing farmland, but they are not the owner of the farmland, but they manage it, but not the owner. And if in the future, or maybe today is even exists, if the technology is replacing all the farmers that are the owner of the farmland, where will they go? If the technology is replacing all many farmers that only managing, not the owner of the farmland, where will they go? And how to solve it? That is my question. Thank you.
Yeah. It's difficult question. So that's why, as I said earlier, technology is only one of the solutions to the challenges in agribusiness, and the use of technology will create a number of side effects. One of them is the unintended consequence mode. I mean, one of the unintended consequence, but in this case, it's kind of predictable, is that some people will lose their jobs. Yeah. So it's a difficult question, because then that's why it cannot be just solved using technology. So there must be some. It has to be supported by policies. It has to be supported by other solutions. Yeah. So I cannot answer that questions because that needs to be. We need to think about it, especially in the context of Indonesia. Yeah. But if I can give you an example in Singapore, but of course Singapore is different. In Singapore, for example, the government, they invested some monies to train the not older generation, but the more older workforce to be ready for Industry 4.0. So about retraining, investing money in retraining people, so that when the Industry 4.0 kicks in, those people will be ready. So they can get they can be transferred. They can switch to a new job more easily. So they will not lose their job simply because now there are new technology, but the government has already prepared them for the new technology. Yeah. So that is an example in Singapore, very different from Indonesia. Because in Indonesia, we also have a lot of people that rely so much on the labor-intensive work. Yeah. So that is something that we have to address. The government needs to address. Sorry, I don't have the answer to that. If I have, then maybe I need to be a politician and become president. No, it's difficult.
Okay. Thank you, Pak Stepan.
But I know that the answer depends on the policy.
Yeah. Okay. The next question from Eric. Jadi.
Okay, hello, Mr. Congo. My name is Eric. Thank you for the opportunities. So as you mentioned before, that technologies are one of the solutions for overcoming agriculture challenges. But my question is, how will those technologies help and affect small farmers that doesn't have any easy access to modern technology? Thank you.
Sorry, repeat again the last one. How?
How will those technologies help and affect small farmers that doesn't have any easy access to modern technology?
Oh, okay. Yeah, good question. I guess it's quite similar to whenever there is new technology, it doesn't have to be Industry 4.0. How can we help the poor farmers to have access to the technology? Yeah. So the typical answer will be a subsidy. Yeah. And maybe some innovative business models in which that we can give loan for the farmers, something that is special loan, not that is maybe subsidized loan or something else. So again, this is where we need innovations. So you're right. That's why my starting point is technology is just one of the answers. Technology, we cannot simply just use technology to solve the problem in agribusiness. So in this case, we need kind of new business models, right, that helps everybody, that helps the farmers to have access to the new technology, but at the same time, it helps the investors, because at the end of the day, they also, we need to create something that is win-win to the farmers as well as to the investors. Yeah. So this is the good thing about you as a agribusiness students or expert in the future. You can think of, okay, I know that the technology can do this. That's my objective, the objective of my lectures. But you need to use your knowledge about business models. So what kind of innovative business models that can help to achieve what you mentioned earlier? So this is where you can apply your skill or your expertise. And then we know that we have tools like modeling or agent-based modeling, some analytics to evaluate your idea before you put it in place in the real world. So you test your idea using computer simulations, experiments, and then you know that, okay, these business models should work, at least on computer, on paper. So yeah, so in short, my answer is you need, in this case, most likely business models or subsidy, in this case, policy. But subsidy, I think we try to minimize subsidy because at the end of the day, it's taxpayers' money. I think the best will be if it is we can find innovative business models.
Okay, thank you, Pak Stepan. Actually, in the Zoom group chat, there are some questions, but I think similar with the question before, this is from Bu Luciana Trimo. They said about the application of Industry 4.0. It's necessary to have good knowledge of information system. But from the result of Bu Lucy research, there are many low and medium